LeetCode Problem 1, shortly referred as toSum. In this problem, LeetCode provides us with one-dimensional array of numbers. It can be 2, I'm taking the case from the problem itself, 2, 7, 11, 15. 2, 7, 11, 15. It gives us an array of numbers, right? And then it gives us an integer called target, and it asks us to do the following. Find integers within this array that add up to the target number and return to me indices of the integers that we added up to return this number. Just to remind you, indices start from 0, or indices of an array, and go up until the last element in the array. So here we have 2 with index of 0, 7 with index of 1, 11 with index of 2, and 15 with index of 3. And logically, without a program, if we look at this array, we can start adding up numbers, right? We can add 2 and 7. 2 plus 7 equals 9. Okay, we found the answer. So what should we return? Should we return 2 and 7, or should we return 0 and 1? Since the problem asks us to return indices of of numbers that add up to 9, we will have to return 0 and 1. As simple as it looks, that's all our problem asks us to do. And here you see the solution, one of the potential solutions for this problem, written in Java. And let's look into it into detail of how exactly this solution iterates through different cases, which are, of course, not only these 3 cases, but these are the cases that we need to sort of pass in order to get solution submitted. Very classical in Java, we start with a class, we create a class called solution. And within this class, we define a method, public method called toSum, right? This can be called anything, but it's best practice to call it something meaningful for the specific class. And we define that the function will return integer array. So it's a public function, it returns array of integers. And what does it accept in order to process, to do something and return you array of integers? It accepts array of numbers, right? Integer numbers, don't forget that, not decimals, but we only work with integers. And that's how we define it, integer, square brackets, nums, and we accept integer as a target, integer target, which is the second number provided to us through the problem. Once we defined our class and our function, we open curly bracket in order to start actually analyzing or doing the logic in order to achieve what problem is asking us to achieve. We start from a loop. A loop is something that will keep doing the same actions until it needs to stop based on the rules. It's similar to you have a conveyor belt and you need to take suitcases from the conveyor belt as they come. And this is basically a loop. You keep doing it, you keep taking suitcases from the conveyor belt until you hit a rule that tells you to stop. Okay, after you take the red suitcase from the conveyor belt, stop. Is this suitcase red? Yes, stop. That's it, okay? So that's how we start our loop. In our loop, we define for. So for whatever will be in the bracket. I, we define a new variable. It's an integer, and we equate it to 0. So in our function, we have a new variable now. I is 0. Okay? I in nums is the array that we receive in the problem. In array of numbers is less than length of numbers. You might ask why it's not less than equal. Well, we cannot equalize it because the length usually starts counting from 1. 1, 2, 3, 4, right? And if it's less, it means that it will stop at 3. That's what we need because there are 3 elements in the array. But if we equate it, it will stop at 4. And then we will hit an error because there is no 4th index. I is defined for an index. That's why we do it less, not equal. So I is less than num's length, and we keep increasing I by 1 with each iteration, I plus plus. What do we have so far? I is 0, we increase I with each iteration, and I is less than length of the numbers. So basically it's an index that will go through each number in an array. Then in this loop, we nest another loop, a nested loop. We nest another loop that will do the following. It will start with one element after I. J will be equal I plus 1, right? So if I is 0, J will be 1. J will be always one step ahead of I. And we again define it J less than num's length. And we will increase J incrementally by 1 with each iteration. Now when we have two loops, now when we told our program what to go through, now we have to define, like, what is the rule? Okay, we went through everything, we analyzed. Then what? What should we do? So for these two nested loops, if nums I means that the element under index of I, don't confuse that, because it's not the element itself. If it's nums 3, then it will be 15. It will not be the element 3 itself, okay? Because there is no third element. There is no element 3. So nums I means the index of the nums array. So if nums value with index I plus nums value with index j equals to target, then we return an array called new. By the way, don't get confused. It's a name of the new array that we define. It doesn't mean that return literally new array. We just define an array that is new and that is called new. It's an integer array and it contains I and it contains j. So that's what we return. Indices of elements that add up to target that we receive. We close the curly bracket for if. We close the curly bracket for a nested loop. We close the curly bracket for the loop itself, and then for the function itself, for the method, we need to define what happens if we can't find a solution. Although the problem says that there is always one solution, it's best practice to define what would happen if solution wouldn't be found, right? We return, again, new array, integer array that is empty. There is nothing in this array. Nothing. Now, when you know what our program does, let's look at it at case-by-case basis, right? We have case 1, where we are provided with an array of numbers and a target. An array contains 4 elements, right? Element 2 has index of 0, element 7 has index of 1, element 11 has index of 2, element 15 has index of 3. So we have 0, 1, 2, 3, right, in the indices, and target is 9. So what does our program does? Our program, it starts running. It gets nums, integers. Okay, correct. It gets target integer. Okay, correct. I have this, right? Program says I have this information. Now we proceed with first loop. I 0 in the first iteration. This is I. I is 2, right? First iteration, we go. We are within num's length because num's length is 4. And we increased I by 1 for the next iteration. Next, we consider j, which is I plus 1. I was 0, I plus 1 is 1. So this is j, right? Again, we are within num's length, and for the next iteration, we increase j by 1. If nums I, in this iteration, nums I is 0. Nums 0 plus nums j. In this iteration, j is 1. Nums 1. What does it give us? 0 is 2, element 2, 2 plus 7. 2 plus 7. Does it equal 9? Yes, it equals 9. If it equals target, we stop the iteration and we return. What do we return? We return 0 and we return 1. I and j. It doesn't matter what sequence it's returned in, as stated by the problem. But again, we try to write the code in the way that it's returned in the correct sequence. So we have solved case 1. Now let's look at case 2. In case 2, we're provided with one-dimensional array of 3 elements with indices of 0 for element 3, 1 for element 2 and 2 for element 4, right? And our target is 6. We start the iteration. Now when we have what we need, I is 0 for the first iteration. So I element equals to 3. For the second iteration, for the nested loop, our j is index 1 because I is 0. We add 0 to 1 and we get j, which is index 1. It is 2 in this specific iteration. Nums I, nums 0 plus nums, what is j? 1, as we see here, right? That's our formula. We get 3 plus 2 equals 5. Is it our target? No, but we are still within nums length, right? That's why we don't return empty array. We have nested loops and we go back to our next iteration. In the next iteration, we incremented I by 1. So instead of I being 0, I is now 1. J is I plus 1, which makes it 1 plus 1, 2. So j is 2. For our next iteration, I is at the position of the first index and j is at the position of second index. And we add nums first index to nums second index, which gives us 2 plus 4, which gives us 6. Is it equal to target? It is. Then what do we return? We return indices of I and j within the iteration where target equal the sum of its elements. And here we return 1 and we return 2. Let's now look at case 3. In case 3, we are given just 2 elements within the array, which is 0 and which is 1. Okay? For the first iteration, I equals 0. We are within num's length, right? I equals 0 and j equals 1 because I plus 1, which is 0 plus 1, is 1. Okay? So our I is 3 and our j is 3. Then when we try to add indices and we get elements of these numbers, we get 3 plus 3, which equates us to our target. And we return 0 and 1. That will be all for problem number 1. If you have any questions, please leave them in the comment section down below. See you in the next video. Bye!